So this we are doing a review of question number 16 from exercise 1 of your module. So that says that, I think I had given you some hint about this last time, but anyhow. So it says that P and Q are at an angle of 150 degrees. Q and R at an angle of 120 degrees. And there is equilibrium of forces. So there are three forces such that, suppose this is P, then this is Q. The angle between these two forces is 150 degrees. This is 150 degrees. And then there is an angle of 120 degrees between Q and R. So you will see that the moment you make that, you will realize that R will have to be like this. Because this angle is 120. And you can see that this angle will have to be 90. Okay. So you have to find the condition, you have to find ratio of P is to Q is to R, so that their sum is equal to 0. And the resultant sum of this is 0. That is the meaning of equilibrium. These are three forces, okay, such that their net sum is an equilibrium. So equilibrium का मतलब क्या होता है? That net force is 0. Okay, that is the meaning of equilibrium. So this basically means that net force should be 0. So that is where this statement comes in. Okay. So the easiest way to do this, since this is a 90-degree angle, is to use component algebra. So you use component algebra here, where what you do is you take this direction as your x-axis and take this direction as your y-axis. So you can then represent the vector P as some unknown times I cap, but the vector Q similarly will become, it's making an angle of 150 degrees with your x-axis. So this angle is 30. Okay. So Q will become how much? It will become minus root 3 by 2 Q I cap plus Q by 2 J cap. And similarly, your vector R will become minus R J cap. So the condition for net force, that is the sum of P plus Q plus R to be 0, implies that now some of these, so you'll see P minus root 3 by 2 Q is your net X component, plus Q by 2 minus R is your net Y component. So this should be equal to 0. So if this vector is 0, that means over here each component is 0. So P minus root 3 by 2 Q should be equal to 0. That means P is to Q is equal to root 3 is to 2. And along with that, Q by 2 minus R is equal to 0. So that means Q is to R is equal to 2 is to 1. So now from this you can see that P is to Q is to R will become root 3 is to 2 is to 1. Okay. What we can do here is simplify matters. You can say that this statement says that if P is equal to root 3x, then Q is equal to 2x. And this statement says that if Q is equal to 2x, then R is equal to x. Okay. So you can take P as root 3x, Q is accordingly 2x, and then accordingly R is just x. So from that you can see the ratio is like this. So this is the simplest way of doing the question. You can do this geometrically also, but I will not get into that right now because I'm doing a quick review of these questions. Okay. So let us just leave this question at this simple solution, which is the which is the component algebra way of solving it. Equilibrium का मतलब होता है net force 0 है. We'll be studying this in detail in Newton's laws. Okay. Equilibrium means that net force is 0. Okay. If a body is in equilibrium, okay, under the action of multiple forces, So automatically that implies that the net force on it is 0. Equilibrium's meaning is that. Okay. We say a body is in equilibrium when the net force acting on it is 0. That is the simple meaning of equilibrium. Alright, so hope this question is clear. Okay, so next we will move on to question number 21. Okay. So Viraj, hope this one is clear. So Tanish, next we are moving on to question 21. The same exercise. So question 21, exercise 1. The module, let's finish this. Okay. So this says that we have the vector E. Okay, Samarth, I will come back to question 20 also. So E is equal to I cap plus 2j cap plus 2k cap. Okay. Samarth, I'll just finish this and come back to question 20. Okay. B is the vector 2I cap plus j cap plus 2k cap. Now we have to find the projection of B on E. So we want to find the projection of the vector B on E. So that is the same thing as along. On means along only. You have to do this. So basically, if this is the vector E and this is the vector B, okay, then what we have to do is we have to find out this one. This is the projection of B along A or on A or parallel to A or any of these things that it is. Okay, so this is theta. So as we've seen that there is a simple formula that we use over here, and that formula is like this: that this component, this projection, will have a magnitude of B cos theta and have a direction of E. So that is A cap. So B cos theta will be given by E dot B divided by mod A. So E dot B here you can see is 2 plus 2 plus 4. Okay. And mod A you can see is square root of 1 plus 4 plus 4. So this becomes how much? This becomes 8 by 3. Okay. So that is your B cos theta. And E cap is equal to vector E divided by mod A. So that is I cap plus 2j cap plus 2k cap divided by square root of 1 plus 4 plus 4. So it is I cap plus 2j cap plus 2k cap divided by 3. Okay. So let's just verify this with the data given in the question. Okay. Yeah, so that's that. So therefore, B parallel, which is B cos theta into A cap, becomes B cos theta, which is 8 by 3 into this whole thing, I cap plus 2j cap plus 2k cap, the whole thing divided by 3. So here, depending on how the answer is given, we can take either the 8 by 3 inside the bracket or we can take the 1 by 3 outside, but it's given in that sense. So I think we'll have to take the 1 by 3 outside. So this will be written as 8 by 9 into I cap plus 2j cap plus 2. So this is becoming our final answer for the component of B or the projection of B along E. So this is the projection of B on the vector. Okay. So hope this is clear. Okay, Tanish. That should be option E in the question. Now next up we'll do question 20, the one just before this. Then we'll move on to exercise 2. But please ask me if there's any doubt in this question. Tanish, hope this is clear. Okay, good. Right, so let's move on to question 20. Question 20 is to do with triangle inequality. So let me explain the question. Exercise 1. So this is saying that out of the following pairs of forces, the resultant of which cannot be 4. Okay? So it's saying that E plus B equal to magnitude है. This cannot be 4 newtons, let's say. If, okay, so the first option is saying that E's magnitude is 2 newtons and B's magnitude is also 2 newtons. You can see that no, it can be in this case, because here E plus B is less than equal to their sum, greater than equal to their difference. Okay, so in this particular case, E plus B can go up to 4 and can go as low as 0 also. It can be anything between 0 and 4. So yes, it can be 4. Okay. So that means this cannot be is the wrong option. Okay. Then it's saying that second option, E and B are 2 and 4. तो इसमें भी हो सकता है, because in this case magnitude of the resultant can be anything between 6 and 2. So yes, here also can be 4. Okay. So that way this is also the wrong option. This is also the wrong option because it's saying cannot be. You have to check in which case it cannot be. So to be careful about what the question is asking also. The next option, let's see, it's saying 2 and 6. So this is also possible. Because here also you can see that magnitude of A plus B का minimum value क्या हो सकता है? Minimum value का difference हो सकता है. So 2 and 4 का difference कितना होता है? 4 होता है. Sorry, 2 and 6 का difference 4 होता है. And sum कितना होता है? 8 होता है. So here also yes, can be 4. So this is also not the correct option. So now let us just check out option D. But obviously D should be the answer. So D is A is 2 and B is 8 newtons. So here you can see that E plus B is mod cannot be less than the difference of these two, 6, and cannot be greater than the sum, 10. So it is between 6 and 10. So here you can see therefore magnitude of A plus B, it cannot be 4 because 4 is coming below 6. Okay. So this becomes the right answer. So D should be the correct option. You can just check for me the answer key, but I've not gone through the answer key in detail, but should be the answer D. Okay, people, moving on to exercise 2. Does anybody have doubts in exercise 2? Any doubt in exercise 2, people? I have not received anything yet for exercise 2. I have received a couple of doubts for exercise 3. Okay, please let me know if you have a doubt in exercise 2, any of you. Okay. Viraj, second question of exercise 2. But before that, Samarth, hope this question is clear. Question 20 is clear, Samarth? Okay, good. So now moving on to exercise 2, question number 2 we will start with. So question 2 of exercise 2. Just go through the question, people. I'll explain. So this is the type of question you have to be very extra careful, because you have to check each and every option. So the question gives you that the vector E is this thing, 2i plus j plus k. Okay. And the vector B is I plus j plus k. Now we have to check each of these options. Okay. So saying that a unit vector, okay, perpendicular to E is minus j cap plus k cap by root. So let's check whether this option is correct or not. Okay. So first thing we have to check here is check if this is a unit vector, because it may not be a unit vector. No? So let's check that thing first. Okay. So the first thing we'll do in this part is we'll check if the given thing is a unit vector or not. Okay. Is this a unit vector? So let's check. So magnitude of j cap minus j cap plus k cap by root 2 should be equal to what? It should be root of 1 by root 2 whole square plus 1 by root 2 whole square. So that is square root of half plus half. That is 1. So the answer to that is yes. Okay. So now we can say that, okay, therefore minus j cap plus k cap, the whole thing by root 2, is equal to some unit vector. It's a unit vector. Okay. Now next thing we have to check is that whether it is perpendicular to A or not. Okay. So we have to check this thing also. Now next thing we have to check is that check if n cap is perpendicular to E. Okay. So for that what we'll do, n cap dot E should be equal to 0 if they are perpendicular. Okay. So this unit vector n cap, इसका किसके साथ डॉट प्रोडक्ट 0 होना चाहिए, E के साथ डॉट प्रोडक्ट 0 होना चाहिए. Okay. So this unit vector is minus j plus k, the whole divided by root 2. इसका डॉट प्रोडक्ट with E, which is 2i plus j plus E, कितना है? It is 0 minus 1 by root 2 into 1, okay, plus 1 by root 2 into 1. So that is 0. So that means that yes, n cap is perpendicular to the vector A. So therefore option A is a correct option. So this is how we have to actually work out these type of questions. That's why you can see that more than one option type of questions are very lengthy and tedious, because now it's not just single option is correct. Na? So A sahi ho gaya, uska matlab I cannot move on from the question. I have to still check B, C, D whether they are correct or not. Okay. So these are the type of questions you get only in the JEE advanced pattern, not in the JEE mains pattern. Okay. And in this type of question, you have to painstakingly check each and every option. Okay. So like I've checked for option A, we have to. Okay, Arshit, I'll explain. देखो, ये जो vector है, वो क्या है? ये vector है. Let's say this vector is some n. It is minus j cap plus k cap by root 2. So that is minus 1 by root 2 j cap plus 1 by root 2 k cap. So this is the vector's x component, y component. Okay. And this is the vector's z component, okay, for this vector. So therefore the magnitude of this vector will become what now? The magnitude of this vector will become root of its x component square plus y component square plus z component square. So x component is 0. This is 1 by root 2. 1 by, okay. So that's how we check. So that's telling us that yes, it's a unit vector. It's telling us that it's a unit vector. But that's not the only thing. I have to check whether it is perpendicular. Yeah, Tanish, if a section is saying more than one option is correct, then I'll show you what the final answer has to be. Okay, so let me complete the other steps. I'll show you. Okay, now let's come to this second part of this. Now the second part of this is saying that to check if a unit vector parallel to E is 2i cap plus j cap plus k cap by root 6. Okay. Now, what is the easiest way to check this? The easiest way to check this is, given the vector E was what? It was 2i cap plus j cap plus k cap. So the vector E was 2i cap plus j cap plus k cap. Okay. Therefore, we directly know the unit vector parallel to E is nothing but its own unit vector A cap. Okay. It's nothing but this one. It is nothing but vector E divided by its magnitude. So E cap should be equal, sorry, E cap should be equal to the vector E, which is 2i plus j plus k divided by its own magnitude. So it should be this vector divided by its own magnitude. So it should be 2i plus j plus k divided by square root of 4 plus 1 plus 1. So that's root 6. So that means A cap is equal to 2i cap plus j cap plus k cap. The whole thing divided by root 6. So that means yes, option B is also correct. So therefore, option B is also correct. So now I have to check C and D, but definitely I know that options A and B are both correct. Okay. Now similarly, you people check out option C and D yourself. You finish writing this down. No, Sarvesh, in NEET there are only single option MCQs. More than one option correct questions are only there in JEE Advanced. JEE Advanced has different sections of questions. Like you have in JEE Mains, you have MCQ questions and integer answer type questions. Like that in JEE Advanced, there are few more sections. Okay. So those sections are pertaining to what is there in your booklets. Yes, Tanish, the section will clearly specify in the exam. Like there will be section 1, so that is only single option questions. Then after section 1, there will be section 2, which will specify that in the next few questions, from question number so and so to question number so and so, more than one option is correct. Then the marking pattern will also be specified. The correct answer question marks and the wrong answer negative marks, all this will be specified. Yes, that is correct in fact, Samant. So to get the question correct, you have to mark all the correct options and none of the wrong options. So suppose the correct answer is AB, then A alone is considered a wrong answer, B alone is considered a wrong answer, AC is considered a wrong answer, ABC is considered a wrong answer. Only A and B will be considered the correct answer, if that's the case. So that's why these type of questions are more tricky. Yeah, syllabus is same. Syllabus of NEET is the same as JEE. Only difficulty level of questions is much less. And yes, Yasmit, to answer your question, we will be completing the doubts today and then we'll be taking it from there. Okay. First priority is to complete the doubts. Okay, now similarly, if you're checking option C, option C is saying that a unit vector perpendicular to B is this one, minus j cap plus k cap by root. So similarly, what you do here is first check, is this a unit vector? So check magnitude. So you'll see that yes, magnitude of minus j cap plus k cap by root 2 is the same vector, is 1. So that's fine. Secondly, check dot product with B. Okay. And you will see that the vector B was given to us as I plus j plus k. Okay. So you'll see that dot product of this and this is, it will be 0. So yes. Okay. So that means option C is also becoming 0. Yes, is correct. Okay. So this is how we check. So this is the same process as option E, but we are now checking for B and the given unit vector, not A and the given vector. Okay, now option D we can see is obviously wrong. Okay. Because see, what is option D saying? Option D is saying that the unit vector parallel to A is I plus j plus k by root 3. But we've already checked here that A cap is 2I plus j plus k divided by root 6. So you can see that this is not the case. Okay. This is not the case. So therefore, this becomes the wrong option. So the correct answer in this question is just ABC. Okay. So question 2's answer should be ABC, not D. Sujal, it is that only. There is no correction in the question. The answer is ABC only. But हाँ, अगर A की जगह B होता, then option D also would have been correct. But in this case, the answer only is ABC. You getting my point? Okay. Anything else in exercise 2, people? Okay. Yeah, Yasmit, I'm coming to exercise 4. Let me just come in serial order. Okay. So exercise 2, anything else, people? Please let me know. Okay, let's move on to exercise 3 then. Exercise 3. Any doubts? Okay, very good. So then let's move on to exercise 4. So exercise 4, I have already been asked to solve. Where is it now? Question 1, 2, 3, and 7. Okay. So let me start with. Okay, very good. So let me start with question 1 of exercise 4. Okay. So it says which of these are meaningful. Okay. So for example, in 1E, the expression says E dot B dot C. Now you can understand this is not meaningful. Why? Why it is not meaningful? Let me explain. Because the quantity inside the bracket, ये कैसा quantity है? Because b dot c, okay, this is a scalar. So let us say, suppose b dot c is a scalar quantity which is x, then e dot b dot c is dot product with a scalar. So this is not meaningful because dot product, okay, this thing, okay, is applicable to vectors only. It cannot be applied to a vector and a scalar. Okay. So hope this concept is clear. Now similarly, you will see that if you look at option B, it is E cross B dot C. Again, it is not meaningful. Why it is not meaningful? Because B dot C is a scalar. So we cannot take cross product of vector E with a scalar quantity, which is B dot C. Okay, so that's why it is not meaningful. Okay. Whereas, let me show you one option which is meaningful. Okay. If you look at this option now, E dot B cross C, you'll see that yes, this is meaningful. Because B cross C is a vector quantity. Okay. So we can take the dot product of the vector E with the vector B cross C, because this is a vector and this is a vector. Okay, so it makes sense. Okay, so this is how you will deal with all the parts of this. Okay. So I'm just going over all the parts now. So similarly, you will see that if you talk about this one, again, yes, this is meaningful. Why? Because we have got, this is a vector and this is a vector, and in between we are taking cross product. So vector cross product with vector makes sense. Similarly, if you look at option E, you will see option E is E plus B dot C. Now this is not meaningful. It is not meaningful. Why? Because you can see that this quantity is a scalar, whereas this quantity here is a vector. Okay. And in between you have got plus. So we cannot sum a vector and a scalar. So this doesn't make sense. Okay. But similarly, if you look at option F, you can see that that is making sense because you've taken E plus B cross C. Now this is meaningful. Why? Because this is also a vector and this is also a vector. So you can add vectors. Makes sense. Similarly, the option G, you've got 5 plus E. You can see that no, this is not meaningful. Because again, this is a scalar over here. You cannot add a scalar with a vector. Okay. But the final option H, you can see that one makes sense. Because there you got 5 plus E dot B. So this is meaningful. Why? Because this is also a scalar. And this is also a scalar. So scalar plus scalar is allowed. Okay. But here a scalar plus a vector is not allowed. Okay. So this is the kind of logic you have to use in this question. Okay. So next I'm going to come to question 2. Okay. So just go through this once if you like before I come to question 2. So this was question 1 of exercise 4. Okay, yes, I'm coming to question 2. Yes, Srishti, that is considered as a scalar quantity, and depending on whether that number is positive or negative, the vector's direction becomes same or it becomes reverse. Okay, so for example, if we write vector B is equal to 3 times A, that means vector B's magnitude is 3 times vector A's magnitude, and B is along E. Whereas if we say another vector is minus 2 times E, that means C is opposite E. The direction is opposite, but again the magnitude of C is 2 times the magnitude of E. So that is the multiplication of a vector with a number or a scalar quantity. That number will be counted as a scalar quantity. That's correct. It will be counted as, if it's just a number, is what we call a dimensionless scalar quantity or unitless scalar quantity. Whereas if we write an equation like this, F is equal to ma, here m is again a scalar, but it's not unitless. It has the unit of kg, but it has the dimension of mass. Whereas acceleration is a vector quantity having the dimension of acceleration or velocity per unit time, or the unit of meters per second square. So the unit of force becomes kilogram into meters per second square. Whereas in this equation, I'm just writing B is equal to 3A. So 3 is just a number. It's not in kg or seconds or anything like that. So hope this concept is clear, Srishti. Okay, so I'm just taking you through some of these options. Then we'll come to question number 2. Yeah, Srishti. So this is not in relation with dot product and cross product. Okay? Dot product and cross product apply to two vectors. So that's a different thing. So A dot B is a completely different thing compared to n into A, where n is just a scalar quantity, or for that matter compared to A cross B. These three operations are completely different. This is the scalar product of two vectors A and B. This is the vector product of two vectors A and B, or the cross product of two vectors. And this is a simple multiplication of a scalar with a vector. So all three operations are different. Okay. The dot product and the cross product, they can only be applied on two vectors. Whereas multiplication of a vector with a number only happens when one is a scalar and the other is a vector. So these two are vector operations, and this is a simple multiplication of a vector with a scalar. Okay, Vita, Srishti, is this point clear? Okay, good. Okay, now let's move on to the second question. Of exercise 4. So this question is saying that we have a force acting on a charged particle, which is given by Q into V cross B, where F is actually, we will see this equation later in physics. It's a very famous equation. It is called Lorentz force. Okay. But anyway, here F is actually a vector, and in fact it is the force vector. Q is charge, so it is a scalar quantity. Okay. But keep in mind that Q can be negative or positive. Like for example, you know that an electron has negative charge, a proton has positive charge. So there are two fundamental types of charges, negative and positive, whereas B is actually magnetic field, but we won't get into that over here. The important thing is that it is also a vector quantity, and V is actually velocity of the particle, but again, without getting into the specifics, there is also a vector quantity. So these three are vector quantities, whereas this one is a scalar quantity. Okay, so the relationship is given like this. Now in each of the options, so in option 1, it is shown to you like this, that if this is your X, Y and Z axis, and option 1, the magnetic field vector or B, capital B vector, is along the Y axis. So your B is like this, and your velocity vector is along the negative X axis. So B is like this. Whereas in case A, Q is positive. So what about the direction of F? Okay. So let's get back to the relationship between these here. So see that the relationship between force, charge and velocity is this. Okay. So since Q is a positive quantity, therefore force is along the direction of V cross B. Okay. Now what about the direction of V cross B? ये कैसे निकलेगा? So we can use right hand palm rule. So use right hand palm rule. So imagine you're looking straight in the XY plane, okay, and your velocity vector is like this, okay, and your force vector, your magnetic field vector is like this. So how you'll have to place your hand? You'll have to place your right hand such that you place your thumb along V and your fingers along V like this. Now this is your right hand. So you'll see that you're looking into your knuckles. Now your palm will be facing into the plane. Okay. For V cross B. So V cross B का direction क्या है? Into the plane. Okay. So in this diagram, that into the plane will be where? It will be along the negative z axis. This will be the direction of V cross B. So therefore the direction of F is along negative z axis. Understood this? So just make a note of this this part first, then we'll come to the other parts also. Okay. All right. Now in the same thing, what happens if the charge of the particle is negative, Q is negative, okay, then F is Q V cross B. So it is a negative quantity into V cross B. Okay, so therefore F's direction will be opposite to V cross B. Okay. So for example, suppose the charge is minus 3 coulombs. Okay. So then your force, which is QV cross B, will be minus 3 times V cross B. Okay. So this is telling you that the magnitude of your force will become 3 times magnitude of V cross B. But direction of the force will be opposite to V cross B. Okay. So you can also understand that opposite to V cross B will be also meaning that it will be along B cross B. Because remember that E cross B is minus of B cross C. So therefore, E cross B is opposite to B cross C. So that's just keeping this thing in mind. Okay. So anyway, back to your diagram over there. So you can see that in this case, if the charge is negative, the force will be positive z axis, because V cross B is along negative z axis. Okay, so like this. Okay, so one more thing I can do here is, instead of this right hand palm rule, okay, so alternately, instead of the right handed palm rule, we can also use component algebra. So you can see this was along axis j cap, and the velocity was along negative x-axis in the diagram, if you recall. So we can write the velocity as minus v I cap. So in the first case, if q is positive, that means the force is q into v cross v. Okay. So this will become q into minus v I cap cross capital V j cap. So now you know that will become minus q v v I cap cross j cap, which you know is q. So it will be minus q v v j cap. So from this you can see both the cases actually. So you can see that if q is positive, then f is along minus k cap, and case b, if q is negative, then it becomes negative into negative positive quantity. So it becomes a positive quantity into k cap. So the force is along positive z axis or positive of k cap. It becomes along k cap. That is, here it was along minus k cap. So this is another way in which we can approach the question. Okay. So just note this down, and I want you to try out the other two parts of this question yourself using either of the two methods. You can use either of the two methods and try out the other two parts. It really helps cement your understanding of cross products. Just try this out. Okay, so people, second part, all of you must have understood that the vectors v and b are becoming perpendicular to each other. So, sorry, parallel to each other. So there is no cross product. The cross product is 0. And the second part, you can see that the velocity and the magnetic field capital B vector, both of them are along the y-axis. Second part. Velocity and capital B, which is your magnetic field, they are parallel vectors. So B is parallel to B. Therefore, V cross B will be 0. So therefore, F is going to be a null vector, whether Q is positive or negative, both the cases. It doesn't matter because V cross B is a null vector. So that's a very easy part. And the third part you do in the similar way, which we done earlier. In third part, you will see what is happening is our velocity is along the negative y-axis and your magnetic field is along the z-axis. So velocity vector is pointing downwards and magnetic field vector is pointing along the z-axis. So B you can write as some magnitude into k cap, whereas velocity will be minus of V j cap. Okay, so therefore V cross B you can see is minus V j cap cross V k cap. So it is minus VB j cross k, which is minus I. Sorry, which is I. So this becomes minus VB I cap. This becomes our V cross, which you can also see by the right hand palm rule here. If you do V cross B, it will point in this sort of direction. Point like this. This is your direction of V cross B along the negative x-axis. Okay. So now you can see that your F will be QV cross B. So that is minus QVB I cap. So Q being positive, F is along minus I cap, and Q being negative, F will become along plus I cap. So that will become your answer. Okay, so hope the third part is also clear for question 2. Okay. Next, we have to do question number 7. Okay, people, let's come to question 7. Okay, so this one is saying that a ship is standing at the point which is the origin, and it sets out to sail at a point 120 kilometers due north of O. Okay, but it gets blown to 100 kilometers to the east to the point B, taking the east direction as I cap and north direction as J cap. Find B. Okay, so let us say this is our y-axis pointing northwards, and this is our x-axis pointing eastwards, as the question is instructing us to do. This is the origin. So according to the instruction of the question, the point E is over here. It is 120 kilometers to the north of, so its coordinates are 0, 120 in kilometers. Where is the point B? Because it gets blown east of the point O by 100 kilometers, so it is 100, 0 in kilometers. Okay. So now we can see what the question is asking for is the vector BA, which is nothing but the vector from B to E, which is this vector. So this is what we mean by the vector BE. It is like a displacement vector. It's a displacement, okay, from B to E. That's why it's pointing from B towards E. So you can see that that vector BA, it has an x component of -100 and a y component of 120. Because you can clearly see that this vector, when you drop the x component of it, that's this one. And when you drop the y component of it, it's this one. So the x component of the displacement is -100. It's pointing along the negative x direction and its magnitude is 100. Whereas the y component of that displacement vector is +120. This is the displacement. Yes. So hope this question is clear, people. Please tell me if there's any doubt. Anything else in exercise 4 you want to discuss? Any other question? Okay, good. So we will wind up vectors now. We're almost done. Just a couple of special theorems I want to discuss, which will be very useful in our next chapter of Newton's laws. So, very last part of vectors. Some useful theorems. So the first one is to do with resultant of equal magnitude vectors. Okay. You can also treat this like the rhombus theorem. So the statement of this theorem is, if magnitude of E is equal to magnitude of B, Suppose that is equal to some x units, and the angle between A and B is theta. Okay. Then, by definition, the magnitude of A plus B becomes 2x cos theta by 2, and the resultant bisects the angle between A and B. So it's actually easier to remember this visually. So I'll explain it like this. So geometrically, what happens is, if your vectors A and B are, suppose, something like this, such that magnitude of A is equal to magnitude of B, which is x, and the angle between them is theta. So mod A is equal to mod B is equal to x. Okay. Then according to this theorem, what should happen? The resultant of primary diagonal of this parallelogram, that should bisect this angle. So this should be the resultant of A and B. So what it should do is, it should bisect this angle. This should become theta by 2. This should become theta by 2. Okay. And so the resultant bisects theta. Okay. Or in other words, in our earlier language, alpha is equal to theta by 2. The angle that the resultant makes with this, the vector E, should be equal to theta by 2. And secondly, the magnitude of the resultant, or magnitude of A plus B, that should become 2x cos theta by 2. Okay, this is the statement of the theorem. Just write down the statement, then we will see very interesting ways of proving this also. Okay, but first of all, on its own, this is very useful. Okay, on its own, this is a very useful theorem. Especially when we are doing things like adding forces and all that in the next chapter, we'll see that if we are adding forces of equal magnitude, then the resultant is equal to 2 times that equal magnitude into cos of half the angle. Yes, these are extremely efficient theorems while doing problems in terms of saving time and energy, solving different things. Okay, so you should remember these theorems, both in terms of the statement of the theorem as well as the proof that we're going to do next. X is the magnitude of A, which is equal to the magnitude of B. Yes. Let X is equal to mod A, which is equal to mod. You can take X or A or whatever. Any symbol will do. Okay, doesn't matter. So the important thing is that the direction of the resultant becomes along the angular bisector, and the magnitude of the resultant becomes 2 times the individual magnitude into cos theta by 2. So for example, if we have this situation that there are two forces acting on a body or on a particle such that this force F1 and this force F2 are at an angle theta. If F1 has the same magnitude as F2, equal to, let us say, 20 newtons, and theta is equal to 120 degrees. So two forces F1 and F2 act on a particle. So find the magnitude of the net force and the direction of it. The net force. Yes, that is correct. Yes, in this case it will become. So we can use this theorem directly now. So what we can understand here is that if this vector is equal to this vector in magnitude, so what will happen is this is also having a magnitude of 20 newtons. This is also having a magnitude of 20 newtons, but they are having different directions. So they are not the same force. So when we complete this, we will see that the resultant or the net force will be like this. And it will have to bisect this. So this angle will become equal to this angle. And F net will have to have a magnitude of 2F cos of that half angle. So in this case it is 2 into 20 into cos 120 by 2. That's cos 60. So that will become 20. So the magnitude of the net force in this case will be 20 newtons. And its direction is along the angular bisector of F1 and F2. So this is F1 and this is F2. So as long as this magnitude is equal to this magnitude, the resultant will have to be such that this angle is equal to this angle, equal to theta by 2. So that is the idea. Yeah, we can reduce this problem to a component algebra problem also. Okay, but the whole thing about it is that it applies even without applying. I mean, it can be applied directly without taking the coordinate frame and dividing it into components. You can skip all that work. The moment you are seeing that you are adding two vectors of same magnitude, you can directly apply this theorem. Yeah, that is the point. You can write the xy plane, but the interesting thing about this theorem is that you don't need to break it into components and all that. You can just apply this directly. Whenever you are seeing you're dealing with the sum of two vectors of same magnitude. Okay, so hope this is clear. How we applied this over here. Now let us look at the simple proof of this. So the first method of proving is using components. So let's say I have my two vectors which are like this and like this. The angle between them is theta. Also, it is known that the magnitude of this is equal to the magnitude of this. So let me take small a as the magnitude of vector E, which is equal to the magnitude of the vector. Okay. Now, deliberately, what I will do is I will take my x-axis as the axis which bisects this. I'll take the x-axis along the angular bisector. Deliberately, I'll just do that. And y-axis therefore becomes perpendicular. So deliberately, I'm doing that thing to prove the theorem. So deliberately, I'm taking x-axis to be along this. So this is theta by 2, and this is theta by 2. So let x-axis be the angular bisector of vectors E and B, and y-axis is perpendicular in the plane of vectors E and B, as shown in the diagram. Okay. Just a moment, people. I'll reshare the. Just reboot the whiteboard software. Just give me a second. Okay, so once I do this, now how I can write the vector E and the vector B. So once I've defined my x-axis and my y-axis like this, x-axis and my y-axis like this, what happens is the vector E automatically becomes E cos theta by 2 I cap minus E sin theta by 2 J cap. You can see that in the above diagram. The E vector is lying in the fourth quadrant, so it has a negative negative y component and a positive x component. So this lying like this, no, at theta by 2. Whereas the vector B क्या हो जाएगा यहाँ पे? So it will become E cos theta by 2 I cap plus E sin theta by 2 j cap. So you can see, because I have taken my x-axis along the bisector and the y-axis is the perpendicular one, क्या हो रहा है, उनके x components दोनों के same हैं, but y components क्या हो रहा है, opposite हो जा रहे हैं. You can see the components of B, the y component is along the positive y-axis and it's E sin theta by 2, और E का y component कहाँ है, it is along the negative y-axis and it's E sin theta by 2. So they will cancel each other, whereas the x components will add, and that's how the magnitude will become like this. So therefore, you can see E plus B. Just add these two here, so that will become 2E cos theta by 2 I cap, but plus 0 j cap. So you can see that the magnitude of A plus B will become 2A cos theta by 2, and the direction is along I cap, which is nothing but the angular bisector, because we have selected which is the angular bisector of vectors E. So hence this is done. So it's a very simple way of proving this theorem, and also very interesting geometrical proof in itself, you see. But important thing ये हो जाता है that whenever two vectors are of equal magnitude, the resultant of them become how much? It becomes this. Okay. And direction of A plus B is along the bisector, along the angular bisector of vectors A. That is the important. So that's how we prove this one. Yes, that's correct. Okay, Sarvesh. Yes, we can prove by triangle law method also, and I'm going to do that next. So if you have noted this down or understood this, you can just try out yourself. But that's a little bit more complicated. We'll have to use your recently acquired knowledge of trigonometry and all those little manipulations in trigonometry. No, this is I'm doing a theorem better. Whereas we have done with the question doubts. Okay. I'm doing an additional theorem, and we're looking at the proof of that theorem. Whereas this is the statement of the theorem written on the side. Okay, you'll get the whole video and notes, don't worry. Know that you got locked out in between. Okay, now let us look at the proof of this same theorem using the triangle law, which is quite a bit trickier, but nonetheless it will give us the same proof. Samar, there are uncounted number of theorems in life. I'm giving you the ones which you need right now. Okay. Let us see proof by triangle law. So let's go back to our old and trusted triangle law statement and diagram. This is the vector A and this is the vector B. And this is the angle theta between them. So in this case, the resultant will be this one. And the resultant will be A plus B. Now the general formula that we had seen earlier was that magnitude of a plus b is that terribly lengthy term, e square plus b square plus 2ab cos theta, and tan alpha is that b sin theta upon e plus b cos theta. Now in this we have to apply the condition if magnitude of E is equal to magnitude of B equal to suppose E. So this is equal to this. Now one thing you can see geometrically only, then this angle and this angle will become equal. These two angles will become equal. And then what will happen? Their sum should be theta. So alpha should obviously be theta by 2. So you can understand that from the isosceles triangle itself. Okay, that alpha should be theta by 2. But here, of course, I am going to prove by these two, by equation 1 and equation 2. I am not going to prove it geometrically. I am going to prove by this. Okay. You can see that magnitude of A plus B is going to be this is from equation 1. So here you can take A common, 2 plus 2 cos theta. You can take this as 2 into 1 plus cos theta. Okay. Now this is where your manipulation can start. Okay. Now since cos of x plus y is equal to cos x cos y minus sin x sin y, therefore cos of theta can be written as cos theta by 2. Okay. Or let me break this first like this. So cos of theta can be written as cos of half angle plus half angle. Now apply this over here. Okay, so it will become cos square theta by 2 minus sin square theta by 2. Okay. Now this can also be written as, you can replace cos square theta by 2, sorry, sin square theta by 2 as 1 minus cos square theta by 2. So this becomes 2 cos square theta by 2 minus 1. Okay. So cos theta can also be written as this. Written very easily as this, because in this step what we are doing is we can replace sin square theta by 2 as 1 minus cos square theta by 2. Okay, so we can substitute that here, and that's how we get this. But मैं exterior angle property नहीं use कर रहा हूँ यहाँ पे. I'm just okay. So now substitute this over here. Okay. So this equation this becomes, next thing this equation becomes this. So it becomes E into square root of 4 cos square theta. So magnitude of A plus B, technically it becomes 2A mod cos theta by 2. Okay. But here we can just write it as 2A cos theta by 2 only, because our cos theta by 2 will be a non-negative quantity. Okay. So since theta is only between 0 and 180, okay, so theta by 2 is only between 0 and 90. Okay. So cos theta is only between 0 and 1. So mod cos theta by 2 is, sorry, not cos theta by 2 It's a non-negative quantity. So therefore, we can replace the mod with this. So this is proof the first thing, okay, that the resultant is 2a cos theta by 2. Now, like that, we have to prove that the angle alpha is also theta by 2, which you've already seen in terms of isosceles triangle and exterior angle. It's already there. We can also prove this trigonometrically. No, if f1 is not equal to f2, then there can be any case. Such it's at a particular angle or anything. Then you have to use the triangle law statement or the component algebra. There is no special case. This theorem is for the special case where magnitude of one vector is equal to the magnitude of the other. Okay, yes, Mitch. So hope this point is clear. Okay, this is a special theorem for a special case. So when the magnitude of the vectors A and B is equal, then you can apply this. If they are not equal, then they can be anything arbitrary. No? So it will not be any special case then. It will just be to the values. Okay, next up, let us look at that formula of tan alpha. We also have that one to contend with. And tan alpha, which was b sine theta upon e plus b cos theta, this becomes this. Because mod A is equal to mod B. Okay, so further it becomes cos theta upon 1 plus, sorry, sine theta upon 1 plus cos theta. Now again what we'll do is we'll replace sine theta as 2 sine theta by 2 cos theta by 2 using the formula that's sine of sin x cos y plus cos x sin y. Therefore, sin theta can be written as sine of theta by 2 plus theta by 2. So that will become 2 sin theta by 2 cos theta by 2. ये सब आपने पढ़ा होगा. I think recently you would have studied half angle formula and all that. So we are using this, okay. And we are also going to use this 1 minus, 2 cos square theta by 2 minus 1. This we had seen above. We had seen this. So substitute these. So this becomes 2 sin theta by 2 cos theta by 2. It becomes 1 plus 2 cos square theta by 2 minus 1. So it becomes so this is a very painful algebraic way of doing it. Totally unnecessary because it's just, you can think of it like an exercise in trigonometry. So alpha is equal to theta. So therefore, the resultant bisects the vector G in terms of angle. In direction, it bisects. So useful theorem to remember for for directly applying whenever we are adding two vectors of same magnitude. Newton's laws of motion, Viraj. The next lecture we will be starting with Newton's laws of motion. Yeah, in HC Verma it is, there are actually two chapters. There's the fourth chapter and then immediately after that there's Newton's laws of motion. I'll tell you what to read. I'll be sending you some PDF to read also, Viraj. So that's this theorem. And now the final thing for today is the next theorem. Is equilibrium of three forces, or it is also called the Lami's theorem. So the statement of this theorem is very simple, that if we have three forces, let's say E, B and C acting at a point or on a particle, three random forces like this, but coplanar of course. On some particles. So the statement is that the resultant sum of coplanar vectors E, B, and C is 0. So that means if there are forces, that means resultant force is 0 or they are in equilibrium. Okay. Or if E, B, and C are forces, that means the resultant sum is 0, means that there is equilibrium of the three forces E, B, and C. So resultant of these is 0 if this condition is satisfied, that E upon sine alpha is equal to B upon sine beta is equal to C upon sine gamma. Where going back to the figure, we'll understand what alpha, beta, and gamma are. Alpha will be the angle between B and C. This angle will be alpha, opposite to E. Beta will be the angle between A and C, or opposite to B. And gamma will be the angle between A and B, or the angle opposite to C. Okay. Yeah, this is like a triangle sine law. What in trigonometry is called the sine rule for the triangle. So this is basically the statement is like this. The condition for the sum of the three vectors to be 0 is that A upon sine alpha be equal to B upon sine beta be equal to C upon sine. Where of course A is nothing but magnitude of that vector. B is nothing but magnitude of this vector B. C is nothing but magnitude of that vector. And alpha, beta, and gamma are the angles that are shown in the diagram. Just make a note of this and we'll look at a couple of applications. You'll understand the importance of this. Almost. Okay, so let's understand this with an example. So very easy example of this is if you have three forces acting like this. Say F1 is at 120 degrees to F2 is at 120 degrees to F2. So if F1's magnitude is 10 newtons and F1 plus F2 plus F3 is 0, then find F2 and F3. So no, these are not coordinate axes. These are coplanar. These are coplanar forces. F1, F2, and okay, so they are in a two-dimensional plane. They are in the XY plane like this. I'm sorry, it looks like I've drawn three-dimensional, but they are in a plane. Okay. So you can see that by Lami's theorem, you can see that F1 upon sine 120 should be equal to F2 upon sine. That will also become 120. Because you can see, because this and this are 120, so this must be 360 minus 120 plus 120. So this angle must also be 120. So this is also 120, and that should also be equal to F3 upon sine 120. So if all three angles are 120, by symmetry, magnitude of F1 must be equal to F2 must be equal to F3 equal to 10 newtons. Okay. So it becomes a one-line problem. Okay. Whereas if you did by component algebra, you would have to prove this way. If you want to do this question by component algebra, you have to prove it this way, that now since this angle is 120 and this angle is also 120, you would have to take your coordinate frame like this. You have to take your x-axis like this and your y-axis like this. So this angle would become 30, this angle would become 30, and this was 10 newtons. So you write F1 as 10 j cap. Similarly, you write F2, F3 in component form. So this question would become more lengthy, but by Lami's theorem, you can see you can get this directly like this. Let's look at another example. So in this next example, we have one force, let us say of magnitude 24 newtons. Okay. And we have another force of unknown magnitude, but this angle is 127 degrees. Okay. And we have the third force like this, at 90 degrees. This one, F3. So if F1 plus F2 plus F3 is 0, okay, then find F2 and F3. Okay, so just try this out with me. Check again, yes, no. Okay, so first of all, you realize that their resultant is 0, that means they have to be coplanar forces, and that means that this angle has to be 360 minus of 90 plus 127. So this will have to be 153 degrees. Okay. Coplanar means lies in the same plane, in a two-dimensional plane. We discussed in the last lecture also. So now suppose you are taking this as your vector E, then which angle is alpha? This angle is alpha. If you are taking this as your vector B, then which angle is your beta? This angle is your beta, 90 degrees. And if you are taking this vector as C, then which angle is gamma? This one. This angle is gamma. So the condition for this will become F1 upon sine of the angle opposite to F1, which we just saw, is 153 degrees, will be equal to F2 in magnitude upon sine that opposite angle 90, which will become F3 upon sine of that angle 127. Okay. So that means F1 upon now sine 153 is the same as sine 37, should be equal to F2 upon sine 90 is 1, which is equal to F3 upon sine 127, which is same as sine 53. Okay. So 24 newtons divided by 3 by 5 is the same thing as F2, is the same thing as F3 divided by 4 by 5. Okay. So 5 by 3 into 24 is equal to F2 is equal to 5 by 4 times F3. One 43, sorry, not one, my mistake. This is, just make a correction here. This is 143. Here also. So that's why it's equal to sine 37, second quadrant. Yeah. So F2 कितना हो जा रहा है? 40 newtons. And F3 कितना हो जा रहा है? 4/5 of 40. 32 newtons. So these become the answers. Now we can also do this question by component algebra method, like we did an earlier question today. But there the angles were 120 and 150. Instead of the angles being 127, 143 and 90, the angles you remember were 120, 150 and 90. ऐसा ही question था, but ये angle 120 था और ये angle 150 था. So there I had used component algebra because we had not discussed about Lami's theorem. But you can see Lami's theorem becomes a shortcut. It becomes a one-line solution. All you have to do is write this single line. From this only we are getting everything. So it becomes a very effective way of solving these kind of questions. Okay, people. So with this, we officially complete vector algebra. So I'll be sending you these whiteboard notes. So now, any questions which are pending for you in vectors, make sure that no, everything is done now. Okay, yes, no? Okay. Everything that you know in vectors, I mean that you're going to need in physics part of vectors, that is now done. Okay. Cosine rule is the same as triangle law, beta. जो आप पढ़ रहे हो ना वो triangle में. So difference of two vectors का हम जो rule लिखते हैं, that a minus b is equal to root of a square plus b square minus 2ab cos theta. That one is only cosine rule. That's called in trigonometry, and here it is vectors. Okay, that's the rule. So next lecture we'll be starting with Newton's laws of motion. So I'll be sending you sort of theory notes like a module in PDF, so you can start reading about that also. But more importantly, if anything is pending in vectors, then please complete that. Okay, if you have got hold of H.C. Verma, then from the first chapter of H.C. Verma, second chapter actually, physics and mathematics, there are some questions and vectors in that also, so you can try those out also as additional practice. Okay. So anyway, that's it for today from my side, guys, and wishing you all the best and stay safe.